Hello everyone, welcome to Cypher page, and today we are going to solve Leetcode number 877, that is Stone Game. It is a medium question, and in this game we are given two players, Alice and Bob, and we are given an even number piles, okay, in which all the numbers are positive, and the objective of this game is to end the game with most stones. Okay, so we are given actually a array of positive integers. Suppose this is our array, and uh, you have to Alice and Bob takes turns, and Alice is starting the game. At each turn, the player will take take the number of stones either from this end, either from beginning, or either from end. Okay, so we have to just find out who will win the game, and to find out who will win the game we have to just uh, just a second. Yeah, to find out who will win the game, what we need to do is we need to calculate who will get the maximum number of stones. Okay, and in this game the ties are not possible because the numbers are given in such the manner, all these numbers, that their total sum will be a odd number. Okay, and so if we try to add all the numbers, we will always get some uneven numbers. Okay, if some players take some number. Okay, so how we will approach this question, we will of course use dynamic programming, and here you can see even length is there, piles are positive, and the sum is that. Okay, so what approach we will do? Suppose there is a single element 5, but that is not possible in this case. Suppose there is a single element, because here we are considering even length. Suppose there is a single element, of course Alice will take the first, so Alice score will be 5 and Bob's score will be 0. So in this case Alice will win and we will return true. Okay, because Alice will win the game. What we have to return? We have to return whether Alice will win the game or not. Okay, so what we can say, if there are two elements 5 and 3. Okay, suppose there are two elements, the size is here 1, the size is here 2. Okay, of this array only. If there are two elements, what I will say, Alice has the first opportunity to take the element, so Alice will definitely take 5. So Alice score will be 5, and at the next iteration, what Bob will take the stones, so the Bob's number of stones will be 3. Or we can say, instead of calculating for both, what we can say, what we need to find whether Alice will win the game or not. So if the score of Alice is greater than B, in that case we will return that it is true. Or we can say, if what we can say, if 5 minus 3 is greater than equals to 0, then not 0, because here of course odd sum is odd, so 0 is not possible. What we can say is 5 minus 3 is greater than 0, we will return true. So instead of calculating for both scores, what we can do, for we will only calculate add score, and when there is a time to when the turn is of Bob to select the stones, what we will do, we will subtract the Alice score, subtract it from the Alice score. Okay, so suppose here also we can see Alice will take 5 and he will win the game. Suppose the size is now 3. We have 3 elements. In this case, it's 5 it's Bob will take 4, and he will take again that 8. So what we can say, first Alice take 5, then 4 is subtracted, so it becomes 1, and then 3 is added, so it becomes 4. So Alice will again win the game. Now S is equals to 4. Okay, and we can say we have to check for like we will use this DP, and we have to just check for each like thing. Okay, how we will do it, we'll make let me just, I'm just showing you we will have separate cases. For S is equals to 1, we have 5 as a matrix, then 3 as a matrix. For 3 only, suppose 3 is there, then also Alice will win. 4 is there, Alice win. Okay, for each we have to calculate it like that. Okay, so let me just scroll down. For size is equals to 1, we have to check for this, this, and this separately. In all the cases, Alice will win. Okay. For size equals to 2, we will have this as a matrix, we will have this as a matrix, we will have this as a matrix. For size equals to instead of matrix, I should say array. For size equals to 3, what we will have, this, and we will have this. For size equals to 4, we have like only this as a piles. Okay, for each we will calculate. Now just I'm making a DP array, and we'll iterate it like this. First initialize it by 0. Okay, all the elements, and then what I will do, I will just iterate over using the size. And how I will iterate, I just showed you, these are the difference. Now we have to iterate using like this is the first loop we will use. Inside that we have to just have make 2 pointers I and j. One will be at the start, another will be at the end, and using this we will calculate. Okay, so whether what is possible. So for size equals to 1, and okay, let me just show you the coding part. Okay, I hope you are getting somewhat what I want to say. We will just calculate dp of I comma plus 1. Okay, I just need to going to the coding implementation. So I'm just write the code. First I'm just defining the pile size, that is this. Now what I will do, I will just make a vector, 2D vector, and I will make it a size of n plus 2, and I will initialize all the values with 0. Thereafter I will just have different size. The size can't be 0, so I'm initializing size equals to 1, and size should be less than equals to n, and size will start increasing. Thereafter we will have 2 pointers, let's say int I. We will initialize it with beginning, so int I equals to 0, and j, it will start from end, so it will be s minus 1, and we will continue till j is less than n, and we will increase both the parameters. Now we have to make parity. Whose turn is this? So for that we will can do, for parity, I plus j plus n modulo 2. This will use to check whose chance is this. So for Alice, If parity is equals to 1, then we will write dp of I plus 1 j plus 1 index will be equals to max. Okay, when we will take max? We will take max when we have to add, when there's Alice turns. Okay, this is for Alice. Okay, piles of I plus dp of I plus 2 j plus 1, or we have to take max of this, or otherwise we have to take piles of I plus, or instead I write it like, I write piles outside this, cancel, save, plus, okay, I guess yeah, max of dp of I plus 2I plus dp of uh, I plus 1 j. Okay, otherwise if it is Bob's turn, what we will do, we will write dp of I plus 1 j dp of j plus 1 equals to, this time we will decrease, we have to negate, and we want the minimum of minimum subtraction, so that we can increase the chances of Alice to win the game. So we will do the same thing, dp of, okay, I hope I have written it rightly. Okay, so these are the two conditions, and now we have to return dp of 1 comma n, and I hope this will work if I have written it correctly. So there is a compilation error, this n is not defined absolutely. Now we can see still we have we have to return it. I just forgot to return this. Now we can see that there is a small bug. So there is a small bug. I have to find it out. Uh, should be equal to, no? Oh no, it's not equal to. Sorry, I have made mistake somewhere else. So let me find out it. Okay, I hope you got the approach. Other method is to just return true, because in, if you just check the check, because Alice is the one who will take the uh, first element, and he can take smartly, because we know that the sum of all elements is odd, so he will take in such a manner that he will win. Okay, how it will win? Because the sum is odd, and he knows if he take one time odd or other times even, he will win. So in all the conditions Alice will win. So the simple code for this is to always return true. So this will work. So this is how we will do this question. I hope you got some of the approach. Thank you.